Alright, this is going to be a bonus video on polynomial behaviors, just to give you guys a little bit more practice with this stuff, all the really important terms, and what it means when we're talking about polynomials. So I've drawn this polynomial here, and as we know from prior units, it bends 2 times here and here, and it has 3 roots. So we know that this polynomial is going to be an x to the third or a third degree or a cubic polynomial. That we already know just from looking at it. What we're going to learn today or practice is talking about how we know this polynomial's end behavior, how we can describe that end behavior, what the intervals of increase and decrease are on this polynomial, where the turning points are and how to identify them, the roots, what is the equation for this polynomial, and what is the y-intercept. And really just from looking at this picture, you can determine all of those things. You don't need to have any more information than what you can see right here to determine all these different pieces of the polynomial. So let's start with talking about end behavior. End behavior is something that's given us a little bit of trouble in class, so it took a little bit more explaining than some of the other terms. The end behavior is basically once we are past the furthest root to the left and the furthest root to the right, what is our polynomial doing? And instead of using words like up and down, we're going to use words such as y approaches or x approaches as y approaches and x approaches. So we have to use specific limits here. X is approaching what as y is approaching what? Well, in the case of this end of our polynomial, all the way to the left, we've got a downward facing arrow at this point. So y is moving downward. Let me select a bigger. There we go. Y is moving downward here. And when y moves downward, it goes past -2 right here. Then it passes -3. Then it passes -4. And in the y direction, it's decreasing for eternity. So we say that y is approaching -infinity. All right? So y is approaching -infinity. As x is approaching what? Well, as y is decreasing, we are moving further and further this direction in the x direction. So we would say that y is approaching -infinity as x is also approaching -infinity in this case. And again, as you can see, with this polynomial, as we travel this direction in the x direction, we've passed that final root, and now as far as we go in the negative x direction, the value of this polynomial is going to just keep decreasing forever and ever. So we would say, in this case, that y approaches, and we use this arrow, -infinity as x approaches -infinity. Y approaches -infinity as x approaches -infinity. Now let's talk about what's happening on the other side or the other end of this polynomial. Well, over here, as x increases or approaches positive infinity, y is increasing or also approaching, and let me get rid of that, and also approaching positive infinity. So on that end of our polynomial, we would say the end behavior is that y approaches positive infinity as x approaches positive infinity as well. That's the end behavior. That's the piece that's been giving most people trouble. It's just you visualizing, once we've passed the furthest root in either direction, what is this polynomial doing in the x direction and in the y direction. And for the record, if you want to, you could phrase it the other way around. You could say that x approaches -infinity as y approaches -infinity. That's also true. We just wrote it this way to start with. It works for some people. If you'd rather write it the other way, it also makes sense. So that is end behavior. I'm going to stop the video now and upload this part because this was kind of a long piece, and I'll do the others in another video just to keep the length of these down.